أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي سبحان الله وبحمده سبحان الله العظيم وبحمده استغفر الله اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم إنك حميد مجيد. My today's video topic is primary gravitation and secondary gravitation. In my video number 12, I derived this formula dv2 over dt is equal to minus gm over r square sine beta, where beta is Tahir angle, and v2 square over rho 2 is equal to gm1 over r square cos beta, where rho is the radius of curvature of the associated with particle 2 and v2 is the velocity of the particle 2 in my video number 12. So you can watch that video if you want to get the proof for this. Okay, so beta is Tahir angle, this is cos beta, and this is sine beta. Okay, so when we do the squares of both the right hand sides, we get m2, we multiply with m both sides with m2, and we get the gm1 m2 over r square, the gravitational force couple between the two particles. Gravitational force is not a single force. Gravitational force is a couple, two forces. Let me give you an example. Like if you have binary star systems, two particles attracting each other and revolving in elliptical orbits or circular orbits around a certain center of rotation, then this force, this particle exerts a force on this particle in this direction towards west. Similarly, this particle exerts a force on this particle in the east direction. So both are gravitational forces. So gravitational forces are a couple. You extend this force in this direction, this one in this direction, it forms a couple. So gravitational force is coupled, is a couple. Okay, so primary gravitation is basically two body motion, binary star systems. Okay, so when we square both of them and add them and take the square root, we get gm1 m2 over r square, which is primary gravitation. Primary gravitation happens only when one mechanical force is involved. Which one? The force of gravity. When only one, let me show you this example once again. So these are the binary stars. So they are moving with respect to a certain center called Tahir center of rotation in elliptical or circular orbits. Here in this case, circular orbits, because I don't have the privilege to make them move in elliptical orbits right now. Okay, so they exert gravitational force on each other. So they are an example of primary gravitation. Only one mechanical force, which is the force of gravitation, is involved between the two particles. They are in deep space where there is nothing else, no other gravitational information or gravitational force to act upon one of these. Okay, so no reaction, no friction force, no tension, no compression, etc. No other mechanical forces acting on them. Okay, so when only one mechanical force and only gravity as the mechanical force is acting between two particles, then this is an example of primary gravitation, essential gravitation, fundamental gravitation, binary star systems all over in the universe. Okay, so this is an example of binary star systems. So primary gravitation deals with two body motion, binary star systems, in which only one mechanical force, that is the force of gravity, is involved. Okay, so m dv over dt is the tangential, okay, now we will go to secondary gravitation. Secondary gravitation is also very important. Secondary gravitation is when more than one mechanical force along with gravity, like gravity, friction, reaction, tension, compression, more than one, can be two, can be three. When more than one mechanical force along with gravity, gravity is a little bit more than a mechanical force, but it has got all the characteristics of a mechanical force. So we'll consider it as a mechanical force. So gravity along with another one of these, friction, reaction, tension, compression, if one of these is associated with gravity at the same time, then the example is secondary gravitation. Okay, in secondary gravitation, this does not hold true, because along with gravity other mechanical forces are acting. So this cannot hold. What happens in nature? This breaks up into this centrifugal force, this one, mv square cos square beta r minus m1 d square r over dt square. This centrifugal force is the essence of the primary gravitation. Let me show you. These are the two binary stars. Before the force of gravity had not established itself, this green force was here. Similarly, this green centrifugal force was here. So as soon as we allowed them to exchange details with each other, a gravitational force couple replaced these two forces of this couple, of the Tahir centrifugal force couple. Okay, so this force, Tahir centrifugal force, is this one, mv square or r cos square beta minus m1 d square r over dt square. So this is the centrifugal force. This centrifugal force counteract the attraction of this force, force of gravity. This centrifugal force counteracts the force of gravity exerted by this on this. So mechanical force, inertial force, Tahir inertial force, or the force of Tahir, mechanical force, inertial force. Okay, so this, what happens when another force other than gravity is involved, like friction, reaction, tension, compression, then this Tahirian centrifugal force breaks up into two centrifugal forces. One is mv1 square over rho, where rho is the radius of curvature. The second is m1 dv1 over dt. Now these two centrifugal forces acts on the body. The body is no longer binary star systems now. It has gone into secondary gravitation. One body with acted upon by reaction, tension, compression, friction, etc. Okay, so now we are into secondary gravitation when one force other than gravity is involved. I have proven these three couples in video 18. This couple is out of the plane of rotation. The two binary stars rotate in this plane. This couple, it does not counteract any mechanical force or the component of the mechanical force, so they remain intact and they cancel each other. This one. And this one is a redundant couple. It is neither used in binary star systems nor it is used in secondary gravitation. So I made it yellow. It's a redundant couple. This force is mv square cos beta sine beta over r. Similarly, mv square cos beta sine beta over r. Similarly, these two forces. Okay, so this force is this force. At 90 degree, or orthogonal to the xy plane, mv square over r. This is rotated by 90 degree, the square root of -1, just to show that it's a rotated force. This one is always perpendicular to the plane swept by the radial line. So whatever plane that radial line is sweeping, this this couple will always be perpendicular to orthogonal to that plane. Okay, so now this gravitational force does not throw any projection on these two, so they don't replace any of the component and the other one gets activated, so they remain intact. They don't do anything, so they cancel each other. So these two components cancel each other, and these two components of the force, these two forces cancel each other. So we are left with primary gravitation, centrifugal force, attraction, gravitational force, centrifugal force. Okay, but when a second force other than gravity starts acting on one of the particles, first of all, the binary star system breaks completely. And then our Tahirian centrifugal force breaks up into its two components, extreme components, m1 v1 square over r, m1 dv1 over dt. This is the tangential component, and this is the normal component. Normal to motion in xy plane. This one is tangential to motion in xy plane. This one is orthogonal to xy plane. Okay, so let me show you an example. So the previous one I showed you was the example of the binary star system. Now this is for the secondary gravitation. I will not talk about binary star systems in 2 dimensions only. They don't act in 3 dimensions. As I told you, these two couples cancel each other, one dimension gone. These two forces cancel each other, the other dimension gone. So the only dimension left is this straight line. So it's 1 dimensional or 2 dimensional xy plane. Okay, this secondary gravitation happens in 2 dimensions and 3 dimensions both. I will not discuss the 3-dimensional case. I will discuss the 2-dimensional case. When I solve numericals on 3-dimensional case regarding gyroscopes and other examples, then I will discuss this same thing but with 3 dimensions. Okay, so this is the particle like this in secondary gravitation. This is the origin, this is x plane, this is y plane, this is z plane. So the particle, let's suppose if this is the xy plane, the particle is moving like this. When the particle is moving like this, let's say this is the curve. So this one is the tangential component and this one is directed towards the radial center or the Tahir center of rotation. So this one is the normal component, mv square over r. Mv square over rho, where rho is the radius of curvature of the circle at that point. And this component is this component, mv square over rho. One acting upward and one acting downward. So this one is m dv over dt, this one, and this one is mv square over rho, this component. So this one is, this one is the radial, towards the radius of curvature, and this one is the tangential because it's moving like this. So this is the tangential, dmv, this might be different from this one, m dv over dt, and this purple one is out of the plane, orthogonal to the xy plane. If this is the xy plane, so this couple is out of the plane, one going up, the other going down. If the motion is xy plane, none of the mechanical forces, if none of the mechanical forces project any component on these directions, then they won't be activated, both of them. Okay, so this is the example of the secondary gravitation. I will discuss with the same one when I discuss secondary gravitation in 3 dimensions. This is secondary gravitation in 2 dimensions. Okay, the forces of Tahir are shadow forces or inertial forces. In my video 18, I derived and showed that there are 3 inertial force couples in primary gravitation. Okay, so in my video, I showed, let's say if we cut this here and screen both of them from each other, none of them exert any gravitational force on the other, this will automatically replace with this couple, the green one. So one couple, second couple, and the third couple. So this one is mv square cos square beta over r minus d square r over dt square. This one is m square v square m v square cos square beta over r. Similarly, m v square cos square beta over r. And this couple is m v square cos beta sin beta over r. This is usually redundant. We don't use it in either primary or secondary gravitation. Okay, so I have proven these three inertial force couples in my video 18. You can watch my video 18 and digest it, swallow it, understand it. Science is not that easy. Okay, similarly in secondary gravitation, there are also three inertial force couples as below. So in secondary gravitation, first of all, in secondary gravitation, there is no binary system. One particle is moving and we have to solve that particle, whatever we want to solve. Okay, the particle is moving. Let's say this is the horizontal plane, the xy plane. The particle is moving like this. When the particle is moving like this, then there is a certain radius center of curvature here, which is the cause of this normal force to motion in xy plane, mv square over rho, where rho is the radius of curvature of the path. And this one is the tangential, this tangential m dv over dt, tangential to the path couple. And this couple is always perpendicular to the plane being swept by the radius of curvature or the radial distance. This couple will always be perpendicular to it. So if it's not 3 dimension, this couple won't take part in it. Even in 2 dimensions, this couple takes part. Okay, a lot of things to be done, so can't explain everything in one video. Okay, so it might not be very clear from here because the diagram is not that good. Okay, so this is the particle going on in inertia. So these are shadow forces basically. When the particle is moving in a straight line, the radius of curvature is basically infinity. So this is 0. And if it's moving in inertia in a straight line, the velocity, the acceleration is 0. So basically they are shadow forces. Inertial forces are shadow forces. As soon as they are replaced by a mechanical force or a component of the mechanical force, the other part of the couple gets activated and starts showing its part in the numerical or the example or whatever. Okay, so iota is -1 just to show that the force is, this force mv square over rho is orthogonal to the plane of motion. Otherwise, we don't use this in calculations. Okay, thanks for watching. Subhanallah wa bihamdihi, subhanallahil azim wa bihamdihi, astaghfirullah. Allahumma salli ala Muhammadin wa ala ali Muhammad, kama sallaita ala Ibrahim wa ala ali Ibrahim, innaka hamidun majid.